Hey everyone! Okay, so if my volume is off, then I'm sorry about that. I actually had to change my microphone after last week's stream, since I'm streaming with my microphone here, and Karstein was streaming with his microphone put here. Okay, I can hear myself, which is pretty good. So, yeah, welcome everyone to my, I don't know, 15th, I believe, English live stream. And thank you for being here. Now, what am I going to talk about today? I'm going to talk about today binary exploitation, or actually format strings, which is part of binary exploitation, I guess. But note the basics. I do hope you know the basics. If not, then there are some links to tutorials in the description of this video. I am going to briefly mention the basics, and then I'm going to jump into more advanced stuff. And I'll explain what's the advanced stuff later on. Anyway, KrzaQ is today's moderator, so if you have any questions at any time, then just feel free to ask him either on our IRC or on YouTube chat. And he will pass it to me using some magical ways, also known as voice communicator. Yeah, so before I get to that, let's do the usual weekly news. But, well, this will be like a sort of weird news, not really like what happened in security, since I don't know what happened in security last week. It will be like more, well, random news. You'll probably see me playing with my headphones today quite a lot, because these are new headphones. My old one died, and these don't really fit me perfectly yet. Cool. So let's start with, I have my my beautiful Zoomit program is not turned on. Yeah, now it's on. Perfect. This is KrzaQ's website. Again, as usual, if you're interested into C++, go check out his blog. KrzaQ, I think you should post more in English. I know KrzaQ is posting really a lot in Polish recently, but I really think you should step up in English too. Apart from that, LiveOverflow, as usual. I mean, this guy is awesome. Totally subscribe him. I see he's reaching like 20,000 subscribers. That's really awesome. Thumbs up. And best of luck in the future as well. And I see there are some AVR stuff recently uploaded. So yeah, it's fun stuff. I did program some AVR in the past, but not a lot. I think I did one crack me, like hardware crack me challenge, and then I did a workshop about it. That was like 2013 or 2009? I don't remember. Yeah, well, quite a lot of time ago. Apart from that, yes, InsomniHack CTF. InsomniHack CTF is a CTF I mentioned some time ago. It's basically the offline CTF, probably the biggest offline CTF in the world, or at least in Europe, which happens in Geneva, in Switzerland, so it's quite close, since I work in Zurich. I live in Zurich, so, you know, it's like a 2.5, 3 hour actually train ride, so quite close. And we usually go there, and we won, spoiler alert, we won actually 4th year in a row, so for 4 years now we've been top 1 on InsomniHack. You can actually, on their Twitter, you can see a photo of us holding this, and this is how people who are really tired at 4 a.m. look when they are happy. They're basically like, we are standing asleep and grinning like madmen. I actually like this photo. I find it quite funny, especially, yeah, this is like a total madman grinning face. So yeah, we won. And what did we win? We won actually this stuff, which is silver bars, because, you know, this is Switzerland, so they give us precious metals, because why not? And so yeah, now I have quite a lot of silver bars on my desk, which hopefully will cover the cost of getting there, but that might not happen, you know. And CTFs is like this, that usually even if you win something, an offline tournament, you won't really get enough money to cover the cost of going there. Though there are some good exceptions, thankfully. Now, I actually I was totally carried by my team. Like, I didn't solve a single challenge myself, which I'm a little ashamed of. And why because of this. PJL it was like this. Hey, Ginvey, you like Python, right? So you should look at this PJL challenge. It's probably a Python jail. So I take a look, and it's kernel exploitation. And after, it's like, so it was not fully true. You get a image of a kernel and the RAM disk, I believe, and then what happens is, like, there's a Python script executed which invokes a second BPF sandbox, using a module written in C++ or C, whatever. And that module actually talks with a kernel module, which is somewhere in well, in kernel space, obviously, and they talk using IOCTLs, but there's an API provided to Python to use that IOCTLs, and yeah, and basically, I guess the task was to escape the sandbox. So nobody actually solved it. I spent like 6 hours on this challenge, and when we get to the back in the kernel, we were like, should I continue or should I actually like give somebody else a hand? And the decision was made to give somebody else a hand, and yeah, because this task will probably not be solved during the CTF. And it turned out that was a good decision, but in the end that also means that I didn't solve any challenge myself. I did help out with like 1 or 2 challenges, but that's about it with my contribution. So like kudos to my team, the rest of the Dragon sector, since they basically like carried us. We're really happy with these 2 tasks, like Easy Win, which was solved by Euro, like only 2 teams solved it, and then there's the robot backup, which was solved by Emlen and myself, which was a Ruby web challenge out of all things. Yeah, so that was pretty fun. Now about PidRail and the kernel exploitation, this one, I'm going to actually do a live stream about it next week, Wednesday. I'm going to show this task. I'm going to hopefully have an exploit working by then for it, and show you what was the task about and how to do the kernel exploitation in the sandbox escape at that time, having, you know, the being able to well, maybe not execute the code in the kernel, because that probably will not be needed, but having a write what were and read what were in the kernel. There's a question: how did the members of Dragon sector meet each other? So a couple of us already knew each other from like various individual and single competitions. Apart from that, well, I obviously knew Mateusz, which is Euro, which like we've been working together forever. And yeah, so that was basically the core of the team. And then some people basically saw us playing and decided to like approach us and maybe ask if we are still looking for members. Then there were people who we thought would be really awesome, and we approached them. So it basically grew really organically. Yeah. And at some point we were like looking specifically for somebody who knows, like, for example, crypto, because we had like 1 guy knowing crypto, but that was not really enough for a top-notch team. And in the end, Redford stepped up and learned a lot of crypto to be able to solve it. Okay. Now, next thing. Oh, this is actually awesome. I don't know if you know POC or Get the Fuck Out. It's a magazine. It looks like this. I have a hard copy, actually. This is a printed hard copy. And it's a hacker's magazine. Like, you know, what kind of hacker magazines were there? There was the one with, like, the frequency of a whistle. You know, the really famous one from Captain Crunch, just 2017 magazine. I think I'm out of 2016. I'm mixing up the frequency. Yeah, that's one of a hacker, one kind of a hacker magazine, if it ever loads. Maybe it will. Yeah. I guess this is the way it looks like. Though I never read it. I think it's available only in the US. Anyway, apart from that, there, you know, the hacking magazine, which is quite infamous for reasons. Then there is the FRAC, which is an ASIN, of course. And then we have the POC or GTFO, which is pretty new one, pretty new thing. And once you start to read it, it's like somebody made it with love, with somebody who like really likes hacking and the scene made it, and it's awesome. It's awesome both on the technical level, and the jokes inside it are like perfect. For example, I don't know, the first thing that you see is the legal note on the top, right? And the legal note says, I don't know if you can see it, I'm going to maybe do this. Yeah, the legal note says, oh, sorry, it's mirrored. Tip the bartender, which is a good legal note as far as I'm concerned. Now, you know that it's made with love when you actually download the PDF file. I'm going to give you the links. Yeah. When you download the PDF file and and it turns out that Andrzej Albertini had his hands on it, and quite a lot of people too. First of all, if you open the PDF, which I'm just going to do, it's there's a MD5 hash of this PDF. The hash of this PDF is something. Now, it might look normal, but think about it for a second. How do you put a hash into a file of that file? Because once you put the hash of that file into the file itself, it changes the hash, right? So is it real? Let's check if it's correct, because it might not be correct, right? I might be just saying, oh, this is the real hash, but it might not be. Let's check it. And yeah, 5EAFOOD, and we have 5EFOOD, the same thing. So it's the correct hash, and actually, how do you do it, right? Half of these articles are about it. So that's the first thing awesome about this PDF. The second thing awesome is that if you change the extension to zip, you can open it as an archive, and all the files which are referenced there are actually here, like actually in the zip archive, which is the PDF file at the same time. Since this is like even more awesome, if you change the extension to NES, which is a Nintendo system, and you launch some emulator, like for example this one, and you launch it in the emulator, you actually get to get a real application for a Nintendo system, which also displays its own MD5 again. I mean, that's just epic. I totally love it. So yeah, I fully recommend you guys checking out the POC or GTFO magazine, both with the newest edition, which just basically got out, I don't know, a week ago or two, and yeah, and all the other editions as well. It seems to be released 3 or 4 times a year. It's really awesome. So yeah, kudos to everyone who is behind this. And now I guess we get to the fun part, which is the format strings. So one thing I want to change about my streams is that I want to prepare a little more for them. When I started streaming, I decided that it's not time consuming, because I just turn on my camera, turn on my microphone, and start streaming, and that's it, without doing any preparation before that. But in the end, that doesn't work so well, as in there are episodes when quite a lot of them when I don't finish what I intend to finish. So I decided to change it, and I decided to spend 1 or 2 hours preparing each episode. This should rise the quality quite significantly, actually, because usually that's the amount of time I'm lacking. So I guess I'm going to go with questions, and then I'm going to show you. I have 4 slides about the basics of format strings, and then I have 1 slide about the advanced things, and then we'll jump into code. So okay, questions first. I have a question. I want to learn assembly and the architecture of Intel and AMD. Can you suggest me some book to read about it? No, I actually absolutely have no idea what books on assembly in English are available, especially for beginners. I just don't know. If anyone has any idea, just put it on chat on our IRC, and I need to do a FAQ section on the website of my hacking live streams. I need to do a website for my hacking live stream, so I can put FAQ there. Yeah, that's a frequent question. Anyway, at some point, a good idea is to actually read or go through the Intel manuals or AMD manuals. I know it's scary. I know it's technical and not written for people. It's written for robots, but it's quite eye-opening at some points, basically. Okay. Apart from that, next question. It also says seafood at the start of a hash. Oh, really? Is that a thing? Seafood. That's true. That's even more amazing. Yeah, come on. That's awesome. I didn't notice. Thank you for telling me. Okay, let's get back to this. Also, I maintain a mirror that includes monoglots. What's a monoglot? if you don't want all the extra file. Okay, so Jordan, I'm sorry, Jordan Vines, I'm sorry if I butchered your name, says he maintains a mirror for if you dislike having like a zip with PDF and just want to read the PDF, like a smaller file. I'm going to give you the links here and there. Yeah, cool. Actually, yeah, since this is a hacker magazine, you are free to print whatever, like print and distribute issues. You're free to mirror it and copy it. So that's pretty awesome as well. Pretty open. Okay, so what's format string about? Basically, format string is like you have a controlled buffer. The buffer contains your input as an attacker. For example, this is the buffer, right? And then you do printf on it. So first you have a buffer, then you read, like the application reads some data which you control into that buffer. I'm actually using specifically read here because if you use read, you don't have to worry about new lines, about tabs, spaces, and like /0, which is a null byte. Read just reads everything, like it reads basically binary data. It doesn't interpret it as text data, which makes things a lot easier. So I'm going to focus on it today. And then once you have it, you run printf on it. So buff is actually placed in the place where the format string should go. And what happens here is that printf is going to be called, right? And when it's called, the argument, the address of a buffer is going to be put on stack. And the argument is actually going to point into your buffer, and we assume that the buffer is also on the stack. And I'm going to actually break this assumption later on, but let's assume for starters that that's the case. And then there's, the return address of printf because it was called, and then some local variables of printf. So printf starts to run and starts to execute this, and there are in the string you pass it the formatting tags, for example %x, which is for display me a hexadecimal number. So where is printf going to get the hexadecimal numbers from? Well, obviously, as this implies, it's going to just like assume that, hey, since this is the argument containing the format buffer, then probably the argument, the formatting string arguments are going to be placed next to it. So this will be the first one, this will be the second one. I'm assuming this is like actually the first 4 bytes, then the next 4 bytes are going to include this space and the first 3 letters, and that will going to be the third argument, then the next 4 bytes, and so on. And I'm saying 4 bytes because I mean 32 bits, because I'm assuming that we are using a 32-bit architecture. If we would be using the 64-bit architecture, in that case we would be talking about 8 bytes. Like each block would be 8 byte and not 4 byte. But let's stick with 32 bits because it's simpler. Yeah, and well, since it will do this, then %x will just grab the first argument and it will display it. So it will display the stuff on the stack, which obviously isn't an argument, a real argument. It's not being placed here. I'm sorry about that. Okay, that was not expected. It's quite funny because I believe the shortcut to display the presentation is actually Ctrl F5, which is the same for reload and clear cache for this website. Anyway, and the second %x will start to display this, which is the buffer, right? So the 41414141 is actually, the ASCII codes of AAAA. So if you put instead of AAA some address here, you could do %s, which stands for the string, to actually display something in memory, or you could do, and here is where we get to this side of the slide, or %n to write something there. And %n actually writes the amount of bytes which were processed or actually written out by printf up until the point where this tags is used. Now, a couple of tricks which are usually used is this. First off is positional formatting. So positional formatting basically allows you to specify which argument do you have in mind. This means that you have in mind the second argument, right? So this 2 here says that I want to use this, basically this, right? I want to use this, and you can specify, like, you don't really have to, because in this case, in this approach, right, you just, if you would want to get to the fourth argument, something like being, I don't know, here, right, or somewhere here, then you would have to just write 4 times this xxx, so the first one would consume the first argument, the second argument, the third argument, and so on. But instead you can just write one with specifying which argument you would like, in this case, which I'm describing, that would be 4, then $, then n. And this is actually a glibc feature. It's not in the standard, if I believe correctly. I don't think Microsoft implements it. It's like a Linux specific thing. So that's one thing. The other thing, okay, how do I get rid of this? Oh, this is how I get rid of this. Perfect. And the second thing is basically the sizes. Since this writes 4 bytes, always 4 bytes, right? You probably don't want 4-byte overrides. You rarely want 4-byte overrides, because if, for example, if you would like to write one pointer, which is 4 bytes, and it is probably a huge number, you'd have to output a huge number of bytes before with printf before %n, the counter of outputted characters, would be large enough to actually be the same at that pointer which you want to write. So usually what you do instead, you use this one or this one. This one just writes, you know, 2 bytes, right? But if you want a pointer, you just use it twice. And this one writes 1 byte, and you use it 4 times to write a 4-byte pointer, which is, I guess, pretty simple to understand. So this is the basic. And what do I mean by advanced string exploitation? Actually, I mean a couple of things. I mean, like the same thing, but what do you do if something is not the case as described here? So here there are some prerequisites, right, which you need to basically to do the exploitation this way. First of all, you do need to have this is going, I'm sorry, I'm totally messing up my shortcuts today. I'm going to try it again. Yes, you totally need to have your buffer, the controlled buffer, on the same stack as the thread which executes printf, right? Otherwise, these arguments will not be here. Second of all, you probably need to leak some ASLR, and you need to know the addresses. So if ASLR is enabled and you cannot leak it, then that begins to be funny. And then you usually have to also write it to, well, write a known value to a known location, which partially is about ASLR again. And you also have to actually have the writable memory somewhere where you want to write, or otherwise, again, it doesn't work. So advanced format string, in my opinion, and that's a personal opinion, it's not like a well-known definition. It's not a definition, right? It's just the rule of thumb, how you think about it. It's either that you're missing a partial, you have a partial ASLR, which means normally you can leak stuff, right, with printf, but you have a one-shot ASLR, one-shot exploitation. And a one-shot exploitation means you have to get code execution in one go, because the application restarts after one go. And so that's one thing. The other thing is, usually you overwrite a GOT address, like for example exit address or whatnot, but the GOT is read-only and you have to use something else. And that was actually the case on the recent CTF, and I'm going to talk about it in a second. And the last one, which I'm going to focus on today, is actually the buffer is not on the stack. The buffer with your format is not on the stack. Where do you put the addresses? Where do you get the addresses from? How can you even like write what where when you don't have the buffer on the stack and the tags cannot find them? So yeah, that's what I'm going to focus on today. There's a question if %2 sorry, I'm going to jump here. There's a question whether this does a padding. I'm not sure if you meant this one or this one, actually. If you're talking about this one doesn't do a padding, if I recall correctly, and I'm pretty sure I would have known. This one, well, it's a normal 4-byte write, so I don't think it does any padding. I don't think there's the question makes sense in this context. If you meant something else, please repeat the question. Okay, and I see there are some more questions. Chigo, thank you for greetings. Where did I find the plugin for Total Commander that has IDA and OLED DBG in a toolbar? But that's not a plugin. I mean, you can just drag and drop stuff here. Yeah, that's how it works. You can just go to configuration button bar and configure this. So that's like fully customizable. And that's it with the questions. Okay, so what I wanted to show you is this. This is the EasyPrint CTF challenge. I might have mentioned it on the last stream or 2 streams ago. Anyway, basically it was like a super simple format string challenge. I'm going to copy paste you the link on both chats. And the problem was that God was read-only. Yeah, this was the problem. God was read-only. So we couldn't override exit, and exit was called just after printf. So my idea in the end was to use malloc, because it turns out that printf actually sometimes uses malloc, sometimes it calls malloc. I might even show you that. Let me open this. Okay, so I guess I need a Linux console, so this should spawn me a Linux console, perfect. And now I'm going to create a file called, I don't know, ASDFC, because that's a perfect name. Naming is hard. Okay. Okay, and if I do something like this, I don't know, GCC, ASDFC, and ltrace. I even have ltrace. I have ltrace. Perfect. I wonder if this is going to do what I would like it to do. I think not, but that might not matter. I'm going to show it to you in a different way. So malloc has something called malloc hook. Malloc hook is basically a function which is invoked whenever malloc is invoked, and it's a global variable which you can just override. If I believe you do man malloc hook, you just find it, yeah. And this is this kind of a function. So you have to create this kind of a function. I don't know. I'm going to call it my hook. Yeah. And I think you are expected to actually call malloc within this, which I'm not going to do. My application is going to probably crash, and I absolutely don't care about it. My hook code, yeah. Just it out, and yeah, return. Perfect. And the malloc hook is equal to this. I set up the hook, and now I compile it again. And declare it. I'm sorry, I believe I do need to use this. Warning, deprecated, blah blah blah, don't care. Okay, and I'm going to run it, and segmentation failed, but that's okay. What this shows you is it shows you that it didn't really call malloc, right? Because if it would call malloc, it would actually call this function, and this kind of function would just write it out. So, but if you put like a width here, and you say that the field is supposed to be over 64K wide, then it's going to actually call a malloc. So if I put 70,000 here and I compile it, and it still didn't do it. You know what? I'm going to probably just... the reason it crashes is probably that it does malloc, like printf does malloc at the beginning for some reason, and I probably should have... No, let me try to abuse it. I'm going to do it like this. Printf and ASDF. Okay, and this should be fine now. Yeah, because printf calls malloc for the first time, and I actually don't implement real malloc here, which means I do need to do this. So again, as you can see here, this function is actually called. So what you can override instead of God, you could override this global variable in the libc, having obviously the libc address, and you can put any code there. And if you do this, if you specify a really wide field for for printf, then it's going to call malloc. If I'm just going to cut a 0 here and to show you that if I cut a 0 there, it actually just displayed it. It never called malloc, right? So this field has to be over 64K wide. And this is what I discovered basically during the CTF while reading the source code of printf. Now, some teams did it in a different way. I actually don't remember who told me that, but we had a chat on the IRC of CTF after it, and we basically exchanged ideas with our teams. How could it be solved in a different way? I would have to look it up who told me that, but one team used, for example, when you output quite a lot of data, right? Flash is called, obviously, right? Because it needs to be outputted, because puts and printf, actually they write into a buffer usually, that's the default. And after the buffer is filled and or something happens, the buffer is I think like 4 kilobytes or 2 kilobytes or 1 kilobyte, something around that. Or a new line is hit and you are connected to a console, then flash is called. Now flash is actually, so a standard output is actually, you know, a file type, right? And file in glibc has a vtable, a virtual table, which has a table of pointers for functions for reading, writing, and so on and so on. And that's because you can use file with different file types, and like standard input and standard output are basically the like default file descriptors, and that's normal. But you can also use file and all the fread, fwrite, and so on operations with memory files, right? So that has to be done that way, so it knows which, it has basically per type vtable, and you can overwrite the address of that vtable and put in the flash position the address, and or even in the write position. I don't know if there's a write. Yeah, probably, yeah. You can put, there's probably a write and there's probably not a flash, yeah. And you can put your address of your code there. So that's the second idea. The third idea was, I believe, you can register your own formatting tags in printf. I didn't know that. This is like a complete surprise to me. I don't know if it's mentioned. It's probably mentioned. I'm sorry. It's not that one. No, it's the third one. Yeah, that's third chapter. You can register your own formatting fields. I don't remember how you do that though. You would have to look it up. Maybe I look for register. No. Custom. No. glibc printf custom formatting tags. Is it possible? Oh, customizing printf. Perfect. Registering new conversions, register printf functions, and so therefore it means that it needs to maintain a list of tags and a list of functions which are to be called. Therefore, you basically can, you know, register using a write what were your own tag and give it your own function, and you can use then a specifier which basically just executes this function. This is like complete news to me. I didn't know printf has such a capability on glibc, so that's actually really awesome. Okay. I'm looking at the questions. Actually, there seem to be some comments mentioning what I already mentioned. Polcher also mentioned that I can set. I don't need to do flashes if I do this. I'm sorry. Set buff std out. No. I think there's also another function for it, like set vbuff or something. But yeah, that's totally true. That's true. In this case, it would act as stdr. stdr is actually something which is, it doesn't have a buffer. It's flashed the moment you write to it. It's being directly written to the descriptor. So that's true. Okay, and yeah, Paul and Mormo and LiveOverflow also mentioned some stuff, but it's what I already said here. So yeah, and I also think that I also like my trick with using malloc hook, and actually this. The way I found it was I just like grabbed printf source code for for malloc. It's because so I've probably mentioned this a couple of times, but it's really useful both in research and in CTFs to have a directory with open source project sources. I call it FOSS, like free open source software, and I have glibc here, obviously quite a lot of versions, and then you look for printf implementation, printf.c. Usually the files are called the same way the function is called. That's pretty awesome. And you can see that it's just a wrapper for this one, so you again look for this file. Yeah, and then you have this thing, and you look for malloc. And it turned out that, yeah, this is probably the malloc I'm hitting, or I think there's another one somewhere close. Yeah, this is the one I'm hitting. There's another one for the precision of white characters. But yeah, this is how I found it and basically how I used it. So yeah, it's good to have such a directory. So this basically covers, did I give you the link to this write-up? I don't think I did. I'm going to give it again here. Yeah. This basically covers this avenue, like you got read-only got, and what do? Well, you do one of these tricks, and I really like the vtable override, actually. This is something I had as my backup plan. If like the malloc thing would not work, then I would go for that. I don't think actually the vtable itself was writable. I think that was read-only, but I think the pointer to the vtable was writable. So you could, yeah, as I said, you could create it. If I'm mistaken, then apologies. But I did check it, and that was my the result of my experiment. Okay, so yeah, so now I'm going to focus on this part. Like, what do you do if the buffer is not on the stack? If you don't have this controlled area, what do you do? And it's actually quite fun. I'm not sure. I hope I'm going to make it, at least to give you an explanation what I'm aiming at. I did write before a stream. Again, having like 1 hour to prepare before the stream is helpful because I was able to write this short code. And what this short code does, it doesn't do too much. It just listens basically on a netsock, on a socket on this port, TCP port. Netsock is, by the way, my library. It's on my GitHub and it's not. I think it's on my GitHub. It's totally on my blog. It's not really a good networking library, but it's a small and easy to use networking library, and I totally need to improve some things there because it's buggy. But it works quite well apart from that being buggy. Yeah, and it creates a server, and then it accepts a connection, and then it forks, right? So it creates a new process, and what the child does, it reads. Read all is basically same as receive all in Python, into the format buffer. Now the format buffer is actually placed here, which is the global buffer, therefore it's not on the stack. We do not control whatever is on the stack. And then it does printf on it, so this is the format bug. Actually the compiler will even tell us that's the case, and it calls exit. And the parent just waits for the child, and that's it. So I wanted the fork here, but I disabled ASLR anyway, so that doesn't change too much. Which vtable I'm talking about? I'm talking about the file object vtable. If you go to, I'm going to actually spend a second here to tell you about it. glibc. Okay. Sorry, and I'm going to look for the definition of file, so that would be struct file. So for programmers, file pointer is actually an opaque structure. We don't know what's inside, right? But I mean, the implementation has to have something inside, otherwise it wouldn't work. Structure file handle, no, that's still not it. Okay, I guess I have to look for it in a different way. Let me just look for this case sensitive full world in a .h file. That's not perfect, but that's something. In which file is it defined? It's probably not here. No, it's probably not here. Trying to look at the file names since they... Oh, lib.io, that's probably somewhere here. Maybe this one? Let's look. No, maybe this one. No, maybe this one then. Oh, because it's called IO file. Okay, then let me look for IO file. Okay, maybe this one. No, you can see by the way the declarations here, right? Of like standard input output and the other global variables. Maybe this one. Maybe I should just look for struct IO file. Not that it helped me a lot. Yeah, it's here. Perfect. So, yeah, this is a file structure. And there are some pointers here, blah, blah, blah. And near the end there should be a... it's complete. It's this one, probably. There should be a... Maybe this one is the... It might be this one, the code vector, codec vector thingy. So I'm going to look for a definition of this one, and it's... Is it this? It's probably this. Yeah, it's probably this function, this table, which has pointers to like out, which is write, probably in, which is read, unshift. I absolutely have no idea. It might be the unget char, and a couple of other file pointers. So you could override one of these pointers of standard output, and using printf then trigger a write, which would be do out, and that's it. Yeah, again, it's all about, you know, the details in the implementation. Okay, let's get back to actually this code. So I did explain this, right? So read to a global buffer, print it in a format string, and then exit, and I can compile it. I'm going to close this. I did write down how to compile it. I have ASLR turned off currently, and I do compile it with no stack protector. It's basically, if I do KrzaQ file on it, it basically has like no canary, NX is still enabled. Why is Pi enabled? But that doesn't matter at all, because again, I disabled ASLR in my system. That's just a virtual machine anyway. Cool, so now I can create a new console, I guess, which would be LCMD. And here it is. And I'm going to run this A out and connect to it using netcat. Netcat is your default tool for doing network operations, obviously. And I'm going to connect to this port. Yeah, and if I type any format string here, as you can see, right, it will... oh, I need to disconnect because it's... what I did call here is read all. It will wait until it will read the whole half of a kilobyte. Now, if I'm going to press Ctrl D, it actually breaks the connection and it outputs the stuff here. I actually would prefer, I would probably need to, and I'm going to do it, I'm going to redirect standard output to actually my socket, because otherwise if I don't do it, then it messes up. It's a too hard scenario and not the one I would like to show you today. Therefore, I need to code that, because I forgot to code it. Man, dup2 is what I'm interested in, and I'm going to do this, and then I'm going to do dup2, and the alt fd and the new fd. I always forget like which one is which one. And the call files, new fd is closed. Okay, then I guess the new fd is being the one which is closed, and the alt fd is the existing one. Therefore, I get this function doesn't exist. I need to get descriptor coded. Descriptor, yeah, that's a good name. And standard output, which is 1. I guess I should close standard output, but I don't really care about it. So this is it. Now I need to uni-std. I believe I have this included, and now I need to actually create this get me a descriptor in this thing. Okay, it's actually a const as well because it will not change anything. Though again, this library was written ages ago. I don't know, 2009. I'm pretty sure I was working still. I wasn't working at Google yet. Sock. Okay, and now I need to, and that's not a sock. Return the socket. Sock, something like this. Yeah, this should work. And I'm going to recompile it again. Did I mean socket? I don't know which. I have absolutely no idea what did I mean. Let me look at these functions. What do these functions actually call? Especially like read, write all. Perfect. Socket. Okay. Socket. Okay, cool. So this should work better now, and I should actually get the output of it. So yeah, let's do it again. Yeah, it works, perfect. So Control D, in sockets you can actually, since sockets are duplex, right? Which means that you can write and you can read from one socket. And if you send Control D, if you type Control D, it actually means that at least I believe that what it means. Please close the outgoing connection. But, well, not really connection, please close the outgoing channel in the TCP connection, but still keep the incoming data alive, which you can just use, you know, normally shutdown for it, so man to shut down. And you specify with, that you want to, for example, shut down write, and it's sometimes useful on a CTF if somebody is stuck on a read, and you want to force close of the read, then you can send, like, do a shutdown this, and this actually sends a TCP packet saying that I'm shutting down my upload, and still it allows it to download the rest of packets which are going to be sent out. So I might have shown the wrong vtable, it seems. At least that's what Svetelin. I'm not sure if I butchered the name. I'm sorry about it. This is the correct one, probably, not the codec one. Might be the case. In all honesty, I don't remember by heart the name of it. Cool. Getting back to this. This works well now. Now I actually need to get my framework. Okay, so what I copied here is the pawn base. The pawn base basically just sets up a connection, and it doesn't do too much other fancy stuff. Yeah, and it just sets up the connection, connects to some port, and then creates a Python. No, sorry, a telnet session. Yeah, so it connects, perfect. I can write to it, can do this. Yeah, okay, seems to work. Now, let's write some Python code. Now, what will be my goal here? First of all, I'm going to scan the stack, and by scan the stack, I'm going to make it display me all the things which it has on the stack. And to do this, I'm going to do, well, use %x or actually %p. That doesn't matter. I can use both. Well, either. Send all. And I need to check what's on the stack, because I'm pretty sure there is not my buffer on the stack, but there will be pointers which I can use on the stack. So to scan this, I need to send a scanning buffer. The scanning buffer will be something like this: for I in range of how far do I want to scan. The buffer is 512. I will need about a couple of bytes for each scan. I start with 32. I'm probably going to, well, maybe increase it a little. That's not a lot. I probably will need to increase it, but that doesn't matter either. So buff is equal this, and then buff. I want to clearly know which argument I'm at, so I'm going to do this, and now I'm going to use the aforementioned scanning primitive, which would be the number. Oh, this is a double format string, this would be funny. The number goes here, then the $, and then X or P. P for pointer. P sounds good. And the new line, because why not? And what I need to put here is I need to put here. No, this is correct. Okay, and then this should emit a normal percentage. Yeah, this is fine. Okay, and I need to start actually from 1 because the arguments start from 1, not from 0. So yeah, and I need to send it. Perfect, and I actually need to align it. So buff needs to equal ljust. It needs to be adjusted to 512. It will be adjusted with spaces. That's fine. Where's my second? Yeah, here it is. Okay, and this is a stack scan basically. You can see it didn't display me any. It didn't crash the application. That's one thing. You can see that child exited. It's 0 here. This is probably the address in the binary. I know because that's a normal. If you disable ASLR, the binary, a pi binary will be put on such an address. I have no idea what this is. This might be the stack, right? I'm going to actually sneak a peek to see where's the stack. To do this, I obviously need to just look in the maps file. So cat proc pgrep a out maps. Yeah. Okay, let's do it again. So the stack is placed here, FFF. Okay. So these are stack addresses, and this is not a stack address yet. What I'm looking for is stack addresses, for addresses which point somewhere on the stack. I actually don't know where my application itself is on the stack. In an easy scenario, and let's assume this is an easy scenario, easy advanced scenario, if that's a thing, we assume that we do know the address of the stack. We can actually do something like this. We can do, how do we do it? I'm going to make it easy. Yeah, let me make it easy. argv. And I'm going to duplicate it, then I'm going to do printf. And I'm going to just send myself the address of the place where the argc is stored. argc. Then I need a couple flashes to make sure everything is transmitted. I'm actually going to add one here as well, but shouldn't change anything. Okay. Now, at the beginning we do get this, which thanks to this we actually know where this is placed, therefore where the arguments of main are placed, and that tells us quite a lot. Now, okay, this is the stack content, and we are going to analyze it. First of all, there's a pointer to argc for some reason. Well, for what reason? Obviously because I just put it here, so therefore it's this garbage, which is on the stack. I have absolutely no idea why it's repeated twice. It might be because how the code was compiled. Then this is not a stack. I'm only looking for stack pointers. This, on the other hand, this 700 looks like this will be int, right? Like with argc. Then +4 will be argv. +4 will be envp, so that would be 8. Then at c I have no idea what, and this points somewhere after it. It might point to, I don't know, argv1-ish. We can do a string here, a string scan in a second. But 21, that's important stuff. Now, what else do we have here? We can see another pointer, and again a pointer to argc, it seems. Okay, now, what's the idea? The idea is basically that using these pointers, we can use %n to write a value on the stack. Now, why do we need to write a value somewhere on the stack? It doesn't matter, it almost doesn't matter where the value is on the stack. What matters is that we need to first overwrite an existing pointer, the end part of an existing pointer. That's the easiest way to go around it. Ideally also of a stack pointer. And second of all, we need to later use the pointer which we had just overwritten to do a write whatever, basically. So I'll draw you what I'm going after. So we assume that there are some pointers on the stack, right? So there's a pointer 1 and pointer 2, at least 2 pointers, but 2 pointers should be enough for almost everything. And there are some other pointers, and the pointer here points to this pointer, and the pointer, the other pointer, right, points to the second one. Now, we use %n on this one to overwrite the least significant byte, or sorry, this need to be stack pointers again as well, so they need to point to something on the stack. It doesn't have to be a pointer anymore. Yeah, but they need to point to something on the stack. Yeah, so we use it to overwrite the least significant byte or 2 bytes of the address, so this part. And we point it somewhere else on the stack. And by somewhere else, we usually mean, so this pointed here, right? And it could be, I don't know, it could still point here, because why not? Let's assume we want it still to point here. Doesn't matter. Or like we just move this arrow to point somewhere else, like to here. And then here, when we get to this one, we do again %n. And we overwrite again the end of the address, and it pointed here, right, to this place. Now we change it, and we make it to point here, like in the middle 2 bytes. Therefore, when we reach this place with we consume the arguments, like we consume this stuff, which is here, and then we reach this place, and we use again %n, and it has already a change pointer, right, which points to this place. And we overwrite it with part of the address we really want to write to, like for example, like God, right? We want to write to God, so we get a God address, and we write half of the address here using this %n, and then we use %n again to overwrite the upper half. And therefore, when we reach here, we use %n again, and on the new crafted pointer which we have on the stack, and we overwrite God. So this is what we are basically looking for. We are looking for pointers to the pointers on something on the stack, because thanks to these pointers here, we can overwrite partial areas of the pointers which are already on the stack, and using this we can create a new pointer on the stack. Now, there is one trick to this, and the trick to this is, it's quite funny. The trick to it is that you cannot use positional tags. You just cannot, and I'm going to explain you why. Because it does because printf does a copy. Let me do an example maybe. How to create such an example? So I probably should do it with dbg. Yeah, okay, let's do it with dbg. I have an idea how to do it. So I'm going to create a test file. Okay, and I'm going to use the, just found malloc and printf to change some stuff. Okay, I will set a breakpoint on malloc so I can break when printf starts already to parse stuff. And now I'm going to do, yeah, this sounds good. It's just 1 here, so it just prints the first argument, right? And it prints it twice. Sorry, I need a $. Here. I need a $. Here as well, so no, that's incorrect. Yeah. And I'm going to set 1337 here. So on the stack 1337, and I'm going to do this. Now I need to compile it. I need to probably kill this, otherwise I can overwrite the executable, but doesn't matter then. Test C, M32, GGGB. Okay. Break. Malloc. Now, what malloc is not, yes, run. Okay, run. So the first break in malloc is actually the initial one, so I'm just going to continue, and this is the real one, which is probably if I... What's on the stack? That's the big question here. Yeah, this is the... No, this is too small. Maybe this is? What I'm looking for is I'm looking for this value, the large, really large value here. Still not it. Quite a lot of mallocs in this printf if you're not looking for them. Nah, it's annoying. Probably should have done it in a different way. Yeah, okay, this is it. This is the value. Right? Because 10,000 is, you know, 64k, and this is just a little above. So this is the value. Therefore, what I'm going to do is I'm going to look on the stack, and yeah, let me just display the whole stack here. I'm going to look for this 1337 value, which I obviously don't remember, which is what's it in hex. I do need 539. Let's look for 539 on the stack. The stack of printf is rather large, so it's probably not. Oh no, it's here. Though I do need the last. Yeah, it will be somewhere here, because this is where the arguments and the environment variables are placed. This is 1000. So this is probably where the main stack is going to begin. Yeah, it's probably this value. It's the first one on the stack. So I'm going to change it, right? I'm going to change this value to something else. And I need to use this plus 4, f plus 0 plus 4 plus 8. So set and pointer plus 8 equals something else. I'm going to place like 1, 2, 3, 4, or just like 3, 3. Yeah. And if we like look at it again, you can see that the address, what was, yeah, here, it was changed, right? So the memory was overwritten correctly. Now I'm going to continue, continue. And as you can see, it's still displayed this value. Now, if I would be to remove this, both this one, and do the same experiment again, it would actually display the 33, or actually 21 hexadecimal. Now, why is it happening like this? Because, which means, and this is quite important, it means that printf doesn't, when you use positional tags, it doesn't respect whatever arguments you have here. If you change them, it doesn't respect that. It uses a copy, a local cache of that. And it happens like that because when you start using positional pointers, it needs to read nth argument, like a given argument on the stack. And it cannot do it in C, because in C, you can read the next argument using, you know, the varg variable argument API. But you cannot say, like, I want to read, like, 15th argument. Therefore, printf needs to read all the arguments, copy them somewhere into basically create a copy of them, create an indexed array of them, saying that, hey, the first argument is actually on this index, and the second argument is actually on this index, and the third argument is on this index. Therefore, as soon as you start to use positional arguments, you create a copy somewhere in memory for the arguments, and the trick which I described for exploiting this advanced stuff stops to work. It doesn't work anymore. So, we cannot use positional arguments. There's a question if %m is allowed anymore. It's like this. On Windows, it's not, but if you have the proper flags in an executable, like if your executable is really old, then printf's %n is still enabled, and that still works. On Linux, you actually have to specify it works, but you have to if you specify a flag like 45 equals 2 during compilation, then it checks if the buffer, which is used by printf, is actually in non-writable memory. If it's in the writable memory, then it like crushes the application and says, no, I'm not going to run printf with a format string in writable memory, which is actually a good security feature, like mitigation. So going back to my idea, I need to find several pointers that point to something on the stack. I'm going to change my scanner a little bit. I guess I need to recompile this again. I guess I'm going to like close the stream in about 10 minutes. If I don't get to my point during that time, I'm just going to write a blog post about it. And the end 1 hour isn't a lot of time. So I'm going to first read until new line. Before I send it, I do this. Receive until new line, and I don't know. I don't care actually about it too much after thinking about it. I would probably love to know what's the offset between argc and this argument on the stack. Therefore, this probably is that argument on the stack. And I'm going to check it by doing something like this. I'm going to change, like, if I is in 3, then use this, else use this, and actually use s here. Yeah. No, this is not it, which is actually surprising. I actually thought this will be this. Oh no, it's actually overwritten by my buffer on the stack. So that doesn't work. But that doesn't matter either. Where is my buffer on this? No, I won't see it here. What can I output here? Oh, never mind. I don't care in the end. So, I'm going to extend it a little. I'm going to create this buffer will be a little larger, just for the simplicity of it. And I'm going to change this to 200. Okay, perfect. Now I have a good picture of all the stack, and I can just display all the pointers which are on the stack. So I'm going to do that. I'm going to just no, because I'm reading it here, that's annoying. There are like 2 interesting places on the stack which you can almost always use if you are exploiting the main stack of the program, like the main thread, right? And that's the argv pointer and the nfp pointer. And this is it. Here. This is probably the argv pointer, and this is probably the nfp pointer, and this is probably the argc. How do I know? I just guess. I just guessed, because it's probably it. What else could it be? You're looking for an integer followed by 2 pointers, and probably there's nothing after that. So it might be as well this thing, in all honesty. And it's probably the same thing, right? It's a copy. Yeah, it's a copy. No, it's not a copy, because this is not a copy. But it doesn't matter. Now, yeah, this is it. What matters is that this points to a pointer, because, you know, argv is a pointer to a pointer, right? So it's guaranteed that this points to a pointer, and it's guaranteed that this points to a pointer as well. Now, where are these pointers? It's a good question. My guess would be this might be one of them. Let's see where maybe this is one of them. 77. Let's do %s on 77. it 77, right? Yeah. I guessed correctly. This is the argv pointer, the argv 0 pointer. Yeah, argv at index 0 pointer. Which means we can basically use the aforementioned, where are you? Yeah, you can use this pointer to override the pointer which is here on this in this place to point somewhere else, and we can point anywhere on the stack because we are assuming that we know the address of on the stack. And again, using the same trick and the other pointer, which will be this, not this one. Again, I'm looking for this one, yeah. To override a different pointer to point somewhere close. So let's actually try to do it, and I'm going to try to do it with just using these two pointers and doing an 1 byte override of the other pointers to point somewhere close. How much do they differ? This is, I'm just going to note it. Because the important part here is that I found this one on 77, right? And then there is 2 machine word difference. So this is the pointer where NFP points to, which makes sense because this looks like an NFP table, right? Crap. Yeah. So this is 79. That's a pretty lucky guess, and these are, oh, I did copy the numbers. Perfect. Cool, now I can look actually at these. How much do I need to change the one? This one points to 7D8AA, and the other one I need to again remove this, do this, and check. That was 77, correct? Correct. 82. So we are lucky. We are lucky because they point to basically the same area of the stack. So if we overwrite 1 byte of each, we basically can create our own pointer just by overwriting this part. So using, percentage HHN. And we can override this one and this one. We can say, let's say that well, they need to be somewhere after these two. So, and we know the address of 77 is, what isn't? Yeah, that could be, if this is like 8C, we can actually look for 84, this is it. 8A, we can probably overwrite it with something along the lines of 0, 0 in one and 0, 2 in the second. And then afterwards use percentage H and to write 2 bytes here and 2 bytes here. That should be fine. Cool. So let's try to do that. And the first thing I need to do is I need to actually stop using this ones, like the scanner. So again, the buffer, what do we start with? We start with consuming quite a lot of pointers before we got to 21 and 22. It's quite annoying that it's actually 42, because between these we will need the value to change. So I'm going to look for this value somewhere else. And there was a copy of it, right? There was a copy before. So this is 84, there's a copy on 29. I'm going to use this copy because in between I need to use some other tag to change the value of the number of outputted bytes. So yeah, so let's use this too. I'm going to split my window just so I can see my notes. I have no idea what happened to my formatting. Okay. Now, oh, this is what happened to my formatting. Perfect. So, first of all, I need to consume... Can I do it in a smart way? I probably can, but it doesn't matter. I need to consume how many? 28 I start from 1, right? So 28-ish. I need to consume 28 tags. I'm going to use C because C always outputs actually 1 byte. So I know that after this, my counter of outputted, the number of outputted bytes will be just 28. And after that, I'm going to check if I'm in the correct place by using buff, and I'm going to print out P. So the pointer, if it's correct, it should be like this. I might be off by 1, therefore I'm going to check this. Where's my... Okay, do this. And I output this. Yeah, this is the correct address, so I'm in the correct place. I'm going to start initialize a counter, basically. The counter counts how many bytes were outputted, therefore I need to know, like, the percentage n. How many bytes will it write out? So this will change to percentage n, and I want to write just 1 byte, right? And it will write, well, it will basically write, what, 28-ish to it, 28, yeah. Well, write counter to it. So that's fine. And then I'm going to, it will not crash the application if I believe correctly. No, it didn't crash. But 28 is not what I really want to write there, right? But 28 isn't bad either. I mean, we can use any value, but I wanted to use I didn't want to use this value. I'm going to write a function which basically which basically I don't know, I should probably continue with my old name counter. Yeah, I want to put the value here in, which will be the number of bytes I want to achieve, like I want to write, like the value I want to write, right? So that will be v, and it will get access to CNT because it's a nested function. So that doesn't matter. Doesn't matter that I put it upstairs. While CNT counter byte. And while this isn't equal to v, increase I plus no. Yeah. And now I know that I need to write I bytes in order to get the CNT to be equal to that value. Therefore, I'm going to add to buff a a wide field, which will be like this, and I will display C again because that's probably the best tag to do it. And I want to use counter byte. V will be equal. What did I say there? I said 0, 0, right? So yeah, let's do 0, 0. And so at this point, my counter should be, I mean, print it, but it should be, the end should be 00. This either. It's not a local variable. Why can't I use it? I should be able to use this. It's a nested. Whatever. Yeah, I can use it like this as well. I don't care. Okay, it didn't crash, that's a good sign. It seems to be at this value, which is correct. And now I can I'm at 27, therefore I should, oh no, that's 28 here, 29. And I need to go to 42. From here, actually 41, because I'm going to use that again to change the counter number for me. Therefore I need to do this, and I wanted there 2. Okay, and this is fine, and good. And now I need to go to 77 and 79 and actually print them out, because that's nothing to do. So that's wait, that's 41. I'm going to reach 41 using this, and 40 will it be? It's going to write 41 as well, so it uses this for 41, 42. So now I'm at 42. And I want to get to 77, and I want to check if the pointers are correct. So I'm just going to do, now I'm going to here to do the same thing, but then I'm going to write to buff. I'm going to print out 3 pointers actually, and I'm going to, I don't know, use some spaces so I can see these. Yeah, looks fine. I'm sticking my console. Did it work? It displayed. No, it didn't work. Why didn't it work? What did I mess up? Did it crash? Yeah, it crashed. I wonder at what point did it crash? I'm pretty sure it didn't crash here. Therefore, I might have some issues here with addresses, so I'm going to fix that. I got the wrong console. Yeah. So yeah, so I point to null. Probably I'm off by 1. Therefore, I'm going to assume I should put 28 here instead. Didn't crash. But I'm not at the right address. Wait. It doesn't work. Yeah, I'm probably off by 1 or off by 2, which doesn't matter. I'm just going to do this and find it out. 0, 0, 0, and this is not a correct pointer. Might be that I should put this here, or actually instead of this I should 28, 29, and this I should. I'm probably off by 1 in the wrong direction. Yeah, I was off by 1 in the wrong direction, it seems. But it's second, so that should be fine. Why wasn't this fine? Yeah, this is fine. 0, 0, 0. Okay. Okay. So now I get it. I need to do this. No, 41, 28. I need to get less here, 1 less. This gets me to 28, this is 29, this is 30. I want to get to 41, well, that doesn't matter. I need to do just this. I'm going to manually not do the math. I guess I'm too tired to do the math. Okay, this is incorrect again. I need to be 1 further than that. So this. Now I'm 1 further. This is correct. No, that was okay. Because I'm going to use the counter for it. Yeah, this is correct. Therefore, I can use the HHN here. And I guess I can continue to go there. And I output 2 pointers, but so one of the pointer is changed. I'm off by 1 again. I need to do this. Yeah, okay. And I'm still incorrect. Why is it incorrect? The second one is 02, therefore no, I'm off by 1 again, but on the wrong direction, so this should be this. Yeah, this is perfect. Now I have created new pointers, right? And the new pointers are actually pointing to, again, on the stack, but on a different location, basically, where somewhere in the future, where consuming other tags I will finally reach at some point. So what I need to do now is I need to, first of all, replace, well, I'm going to just write to for one. It will crash, obviously, but that's okay. I'm just want to show you how this write what where works, right? So to do that, I need to create a new function, because this is, I'm sorry. This works great for bytes. I want to do it for the words as well. You might say, oh, this is slow and inefficient, you should do a subtraction. Yes, I should, but I'm too tired, as you can see, to do even basic math, so I'm going to just skip it and not bother. Equals counter word, and I need to do one less. Therefore, to do one less, I need to do one less here. Yeah. And I want to reach 41, CNT. Good, and now I need to output this. And now I need to, this is the first write, so it's this one. And after that, I'm going to again do this, because the counter now changed. It's no longer 41 after this. No, it is, but it will change after this one. So yeah, so it won't be corrected, it will be off by 1, but I don't care that much. It's going to be like this. Unless I can create something that writes 0 bytes. I don't know how to create something that writes 0 bytes. And I want to write 2 bytes here and 2 bytes here. And this should not crash the application. Let's see if it not crashes. It doesn't crash the application, doesn't display anything either. And after that, I'm just going to scan for my pointer. Where is my pointer placed in memory? So I'm going to do path p. This might crash actually my application. This is maybe too much. Yeah, space. Okay. And yeah, here's my pointer. This is the 41, 42, 41. Let's just do 42 here, so it's happy. And yeah, it's this one. I'm going to count the number of spaces to know how far is it off. How do I count the number of spaces in a fast way? I don't know. I'm just going to do it manually. 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. Oh, I could went the other way around, that would be way simpler. Yeah. Okay, and we get to did I display the address? It's probably not this address. Off by 1 again, but which direction? Yeah, got it. Cool. So basically now this is the address where if I just replace, right, this p with %n, this is the address I'm going to write to. So even though I didn't have my buffer was not on the stack, I still could create an address on the stack, and I could write to it, or I could read from it. We can actually do a quick check if I can really read from it. Let's read something in memory. So there's the address of the counter, which is being sent to me. Maybe I could read that. Let's do maps. Cat proc pgrep. And I'm going to open my binary in IDA. I'm actually going to write somewhere. I'm going to make the application crash on 41, 41, 41, 41. Okay. First question, where is my image in memory? My image in memory is at this location. Therefore, I need to tell IDA to edit segments and then rebase program address of image base actually. And I put this address here, so now it rebased it, and now I need to look for the GOT, so Control S, GOT, and here are my addresses, and I know that after my code where basically exit is called and exit is at this address. So I'm going to copy this address, and this is the address I'm going to write into memory. Okay, so which goes where? This goes here, and this goes here. So now my %p should display this address of GOT. Run it. Yeah, it does. It's correct, right? Yeah, it's correct. And now I can overwrite it. What can I overwrite it with? Well, I'm going to just overwrite it with anything, because I would like to... Well, this stream is already 1.5 hours. So, before I get here, I do actually one less. So that's 27. And I do this, and I do H. I'm going to do N. 4 buffer override, 4 byte override. And I'm going to set the counter to 41, 41. So there'll be something, 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 41, 41. It probably did crash. Yes, it did crash. Now the question is, where does it crash actually? So I'm going to copy this A out to TMP, because ulimit-c unlimited doesn't work well with Windows partitions on Linux for some reason. Cool. Now I'm going to make it run again. So A out, run my exploit. It should have generated a core file. It's here. GDB A out core. Where did you crash? Where? No, it crashed at a... it probably crashed during writing. Let's see, what did it try to do? So X. What instruction did you crash on? You crashed on... Yeah, trying to write to this address basically from ESI. So IR ESI, what's the value of ESI? Something like this. I have absolutely no idea why. And IR EAX. Did I do enough by 1 again? I probably did enough by 1, didn't I? Oh, I know what happened. No, it shouldn't. Should be fine. I thought about, like, you know, my stack misaligned. But that's probably the case. Probably my stack did misalign because I just changed some environment settings, and I'm playing on the stack, right? So I need to have my stack actually behave in the same way as it did before. I did ulimit-c, it probably changed my stack again. So yeah, let's leave it at here. I'm going to maybe write a blog post on it, but it would work if I wouldn't copy this to TMP. So let's maybe do it in a different way. I'm going to span a new console. The new console should have a fresh environment, and I'm not going to do... What I'm going to do is I'm going to attach a debugger. Now I need to attach a debugger, and I shouldn't actually start to do the debugger, because that will mess up my stack again, because running something in GDB changes the stack layout a little. And now I need to do sudo gdb pid pgrep a out. Okay. Okay, now set follow fork mode to child and continue. And now I'm going to write my run my exploit. Okay. It exited normally. Oh right, because I changed it. So yeah, I need to do it again. Fork mode, child, continue. Changing my exploit this to S, sorry, N to write. Run my exploit. Okay, and it crashed again. Why did you crash this time? Nothing likes me. So that's the correct address, and this is the correct value-ish, kinda correct value, and value isn't correct. Value should be this, and it's not this. It's off by 16. But the address is correct. What probably this means, what's there? Yeah, it probably means that this area is read-only on my Ubuntu as well, so I cannot overwrite it. But as you can see here, is basically, it worked, it did attempt to write there, so it is a write what were condition, therefore this is exactly what I wanted to show. So, okay, first of all, sorry for running late with it. Second of all, I will probably push this code to my GitHub. I'm going to create a new repository called stream.em on my GitHub. My GitHub would be... where is it? GitHub/conveil. Currently there's only one for Polish streams, but I'm going to create one for English streams as well. I'm going to maybe keep them together. No, because I don't have any namespace for English ones. I'm going to create a new repo and push my code there. I'm going also to push the code of a server there, and that's it. Now I'm going to answer a couple of more questions and we'll finalize the stream. So I'm pretty sure it was pretty chaotic. If you already did some like format bug exploitation in the past, I'm pretty sure you actually got everything, and what I showed you was rather slow, so I apologize for that as well. Let's see if there are any questions. Can't I set the proxys kernel core pattern to TMP core? I can, but I never remember the syntax. And okay, I guess that was the only question. So thank you for staying late. Thank you for being here. Next week I'm going to chat about the PJL kernel exploitation challenge. Hopefully it will go a little more smoother than today. Totally kudos to this guy for being here and like staying with me all the well, even though my stream was running 30 minutes late, or like 40 minutes. That's about it. So thank you and see you next week. I'm leaving you with the ending screen and some music. Bye bye.